So, Brandy, looking at this first graph, what is that? It is a reflection. So I'm going to write, I'll do red. This is a reflection. At least what axis is it reflecting over? Yes. And I know it's a reflection because it flipped and because I see a mirror image. What is that?
Dilation.
It's a rotation because you see it turned. Had to turn, and doesn't really say which ones we start with. So let's just assume that this is shape 1 and this is shape 2. So how many quadrants did it move, guys?
90 degrees.
It moved 1, so that's 90 degrees. So this is a rotation. Since it moved 1 quadrant, it would be of 90 degrees. And I know it's a rotation because it turned. It didn't just flip over an axis. There's not a mirror image there. This one is a little bit weird to see. You have this red shape, red triangle, and then it's a blue triangle. Riley, what do you think that is?
A dilation.
A dilation, and it's a stretch because the shape is getting larger. I know it's a stretch because the red shape is just A, B, and C. The blue shape is A prime, B prime, C prime. So the blue shape is a new one. So we got a dilation. Let's figure out by how much. We're going to look at 2 of the points. Let's look at A and A prime and see how much it changed by. A is at 2, 3, and A prime is at 4, 6. So please talk to the person closest to you. How much do you think it dilated by? Davion, how much did it multiply by? Looking at those points. It went from 2 to 4. So what number would we have to multiply by? 2. So this is a dilation of 2. Last one. I bet you probably know what it is by process of elimination. Last one. It is. Because it's a slide. Can anyone specifically tell me? This is shape 1. This is my original. And this is my new one. How did it move specifically? If you feel like you know, you can raise your hand. Elise, go ahead. Yeah. Good. Label this. I'm going to label the original shape with a 0. The first one, A prime, B prime, C prime, D prime, with 1. And A double prime, B double prime, C double prime, and D double prime with a 2. So you have the original, the first transformation, and the second transformation. So right now I want you to ignore this one. I don't care about shape 2 right now. I want to know what happened from 0 to 1, from the original to the first transformation. Would you please tell the person closest to you what happened? How about Francesca, what happened on the first one? You got it.
The translation.
Yes, it's a translation. And Tyler, can you tell me how it translated?
X4, Y3.
X4. Here's what I would do. I would take A and A prime. Let's just track one of the points because all 4 points did the same thing. It looks like it went right 2 and down 5. So this was a translation, right 2 down 5. If we wrote a rule for that, it would be XY goes to X plus 2 and Y minus 5. Okay, let's see. Bella, what do you think? Did it slide, reflect, or turn? It is rotation because it turned, right? And So it's on this line. So it's not really in a quadrant. So guys, how many lines did it move? From like the axis. It was on the y-axis. It moved over here. How many times did it turn?
90. What?
It turned one time to get from here to here. So that would be a 90 degree rotation. Whew. Okay, so you got to be specific. Tell me how it rotated or how it translated, then how much, please. This is the original, and this is the second one. Do you see how it says double prime? So that means that there's something that happened in between. There's two transformations that happened to get from the original to the second one. You can reverse the order of these, it doesn't matter. Anybody have an idea? What do you think? Well, first off, let's look at the original. To get from the original to the second one, do you think it flipped, turned, or what am I missing? Slid. Joanne, what do you think?
I think it dilated.
Okay, do you think it got bigger or smaller?
Smaller.
It got smaller.
I think it rotated.
Here's the thing. Because it's not on the same side of the graph right now, we can't do the dilation yet. If you try to do the dilation right now, like this is 0.22 and that's 0.-1, 1. We need to be on the same side of the graph first. So what do you think happened first? We got to get this over there. What am I gonna do? Help, Jovi.
Reflection.
Yeah, flip it. Flip it over the line to get it over there. So if we do a reflection over the y-axis,
It could be a translation though, couldn't it?
no, because it would be facing the wrong way.
Oh.
It's hard to tell, right? So this is a reflection first. I'm going to go ahead and graph that reflection over the y-axis so we understand where it is now. So let's go ahead and graph it. So that's shape 2. I'm going to graph this first shape in blue. I'm going to reflect it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. B. That's A prime, B prime, and C prime is 4-way. So what I'm doing right now is reflecting the big shape over the y-axis. You should probably do the same to have the work on your paper.
Okay.
See, now it's on the same side, so that was a missing in-between step because I didn't give it to you. You got to figure it out on your own. So then, Brian, we're going to look at these points. I got A, the original, no. I have A prime at -2, 2. And I have a double prime, Seamus, at, what is that, -1, 1? So it went from here to here. It got smaller. Would you please talk to the person closest to you? What did it multiply by? William, what do you think happened? The numbers got smaller. Did they what did they multiply by? William, sorry. By a half. So this is a dilation of 1/2. So it's getting smaller. So we're going to write a dilation of 1/2. So the scale factor is 1/2 because we multiply all our points by half or divide everything by 2. Whenever you're doing these, if you need to use like patty paper to trace and kind of turn things around to see, especially for rotations, that might be helpful. We might actually do that on the next one. Was the transformation from the pre-image to the image of that one that we just did, was it a rigid transformation, guys?
No.
Nah, it was not.
It's similar.
Zachary, why not?
Because they're not congruent.
Yeah. Because they're not congruent.
Is that your voice?
Yeah.
That sounded like her.
It sounded like jungle. Like
So it turned 2 times, so that's a rotation of 180. This is a part where I would get out patty paper if I were you. And I would go ahead and do that transformation because right now, if you do that, it's not going to end up here. So would you please get out a piece of patty paper, trace A, B, and C, and the X and Y axis, and do that rotation of 180 degrees because it will not be that shape because something else happened. After you do the rotation with your patty paper, it ends up here for A prime. C prime is at -4, -8. And B prime would be at, I don't know what that is. Here. Yeah. You got to use your patty paper to do that, or you're going to be a little bit confused. Okay, so now it's at least facing the same direction as the last shape. So this is the original one we just did, and here's the last one, number 2. So how do we end up getting from now the one we just rotated to the last shape? Olivia, what should we do?
Translation.
It is a translation because it's sliding up to that spot. Can someone raise your hand? Can someone be specific? How is it sliding? Like what directions? Alice, go ahead.
Up 3, left 1.
Yes. Translation. I'm going to say left 1 and up 3. Left 1, up 3, left 1. Oh, left 1, up 3, and left 1, up 3. I can check all the points. Because they're congruent. My handwriting's pretty bad today. Yes, because they are congruent.